Hi students, in this session we are going to see the remaining exemplar questions from the chapter Electrochemistry. Okay, so initially we discussed 17 questions before, and I will give the link in the description box. So we are going to start now. So here in this is a multiple choice questions. More than one options could be the answer. Okay, so the question number 18, the positive value of the standard electrode potential of copper electrode indicates what? They have given a set of options. First of all, I will explain you. See, what is standard electrode potential if we connect an electrode to hydrogen electrode? Okay, so what does it says? If we connect copper to the hydrogen electrode, we know that the electrode potential of hydrogen is 0, and they say it shows a positive reduction potential. So what does it says? When we connect copper electrode to the hydrogen electrode, your copper will undergo reduction. And your hydrogen electrode will undergo oxidation. So your hydrogen is going to act as anode, and this is going to act as, your copper is going to act as cathode. So let's see the thing here. See, I told you before, see, this is undergoing reduction. That means it is an oxidizing agent. What is an oxidizing agent here? Your copper 2 plus is an oxidizing agent, not your copper. Okay, remember that. Okay, and this your hydrogen is a reducing agent. Okay, they will undergo oxidation and they will act as reducing agent. So this redox couple is a stronger. This redox couple means they are speaking about the copper electrode. Okay, is a stronger reducing agent than the hydrogen. No, just before we saw it is an oxidizing agent. This option is not correct. This redox couple is a stronger oxidizing agent. Yes, it is true. Copper can displace hydrogen from acid. Can it displace hydrogen from acid? No. Okay, so the reverse reaction cannot take place here. Copper cannot displace hydrogen from acid. So what they mean, if copper reacts with H plus, no reaction takes place. Okay, no reaction takes place. It cannot displace. Okay, hydrogen from the acid. This cannot happen. That's what they mean. Okay, so next question. The EMF of the cell for some half cell reactions are given below. Okay, on the basis basis of this, mark the correct answer. So for the reduction potential, standard reduction potential of hydrogen is given, and for the water, okay, oxidation of water is given potential, and for sulfate ion is given. So they are asking, in dilute sulfuric acid, hydrogen will be reduced at cathode. See students, I'll tell you. See, first option, if they say dilute means there is presence of water. Okay, dilute sulfuric acid. If you are going to do electrolysis, so there are two kinds of ion. This is H plus from sulfuric acid, and this is SO4 ion, 2 minus ion from the sulfuric acid. Okay, and from water it can provide H plus, same H plus, and OH minus ion. Okay, so now there is a competition which is going to undergo. So the cation will undergo reduction, and your anion must undergo oxidation. But which ion? Okay, so we are going to do electrolysis. So here is your anode and this is your cathode. So there is no competition here. So both are H plus ions. So the H plus will move towards the cathode and it will get reduced here. Okay, so sulfate, between sulfate and OH minus, before itself I told you the trick. See, if you have halogens like this, okay, they will oxidize. Preferentially they will get oxidized in the presence of OH minus ions, and the last preference is your sulfate, your nitrite, your fluoride, etc. Okay, so this is the oxidizing order. Okay, this is the order of getting oxidized. Okay, so here which one will win the competition? This is your OH minus. Okay, your OH minus will reach here and it will get oxidized to O2. This is what happens. happens here. In dilute sulfuric acid solution, hydrogen will be reduced at cathode. This is the correct thing. In concentrated sulfuric acid solution, water will be oxidized. See, in concentrated sulfuric acid, there is no water. So how water will get oxidized? Okay, so no, this statement is wrong. In dilute sulfuric acid solution, water will be oxidized at anode. Yes, correct. In dilute sulfuric acid, sulfate ion will be oxidized to tetrathionate ion at anode. No. Okay, so in dilute sulfuric acid, your water is there, only water will get oxidized. Okay, so this is the answer. Now, the EMF of the Daniell cell 1.1 volt is equal to 1.1 volt. Which of the following expressions are correct? Okay, the description of state of equilibrium in the solution. See, first of all, write the Nernst equation. E cell is equal to E naught cell. Okay, so for galvanic cell, you know that is the zinc copper couple. This is a zinc copper couple, and how many electrons are involved? Here n is equal to 2. Okay, minus 2.303 RT divided by NF log Q. At equilibrium, what happens? At equilibrium, what happens here? E cell is equal to 0 and Q will become equal to Kc. Okay, your Q will become equal to Kc. So let's substitute in the equation. So your E naught cell, okay, will be equal to 2.303. Substituting those values here, I know n is equal to 2, so 2f. Okay, log Kc. Okay, here E naught cell value is given, which is equal to 1.1 volt. Okay, so this option is correct. You know that these are all constants, and if I substitute that constant, okay, Kc. Okay, so when it goes here, 2.2 volt divided by 0.95 equal to log Kc. Okay, so this is also a correct option. The rest are wrong. Okay, the conductivity of an electrolytic solution depends on, you know that the conductivity of an electrolytic solution depends on, okay, the nature of electrolyte, okay, and the size of ions. Okay, signs of ions and solvation, how much extent, because solvation will turn the smaller ion to a bigger ion. Okay, and temperature. Okay, and viscosity of solvent. Okay, viscosity of solvent. So, and also the concentration of the electron. If it is more concentrated, it will decrease the mobility. Okay, the nature of the electrolyte and the concentration of the electrolyte, and the rest two are wrong answers. Okay, so now see, the molar conductivity of water at infinite dilution is equal to, you know, water is a weak electrolyte and it will not completely ionize, so we have to use the Kohlrausch law. Okay, so from the strong electrolytes we have to derive the answer. See which option is correct. See, we need H plus and OH minus ions, that is our motive. So H plus HCl, by combining HCl you are getting H. Okay, we don't need Cl. Okay, so plus NaOH. Okay, we got OH also, but we don't need NaCl, so minus NaCl. So this will give you the conductivity of water, molar conductivity of water at infinite dilution. Check whether it will give or not. So hydrogen we got and minus OH, so this is a wrong thing. Okay, so here H we got, OH we got plus OH, but we don't want NO3 minus and Na plus, so minus NaNO3. This is also correct option, and this is a wrong option because NH4OH is itself a weak electrolyte, it's itself a weak base, so we cannot use it, so this is wrong. So what will happen during the electrolysis of aqueous solution of copper sulfate by using platinum electrode? See, we are using platinum electrodes here, which are inert electrode. See, I'll tell you. See, we are using aqueous, so the competition, there are two competition as I told you before, the competition between these two ions here and here. Okay, and we know that this will undergo oxidation, and among these two your copper 2 plus will undergo reduction, because I told you your copper 2 plus, your Ag plus, your Rm, okay, has more, they have more reduction potential than your H plus ions, okay, H plus ions, and lastly your S block elements, please remember this, okay. So the copper will deposit at cathode, this is correct, okay, this is wrong. And what is the next option? Your oxygen will be released at anode, yes, and this is wrong. What will happen during the electrolysis of aqueous solution of copper sulfate in the presence of copper electrodes? See students, the before example it was with platinum electrode. If you have copper electrode is not an inert electrode, it is an active electrode. If you have active electrodes, what you have to do is you have to forget about the anions, okay. So here copper 2 plus will get reduced, this is correct, but which one will undergo oxidation at anode? Yes, your copper itself. Your copper being an active electrode will oxidize to copper 2 plus, okay. So please remember this. If it is an inert electrode, go with the regular procedure. If it is an active electrode, forget about the anions. It is itself the active electrode which will undergo oxidation. So the copper will deposit at cathode, correct. Copper will dissolve at anode, yes, this is also correct. Oxygen will be released at anode, no. Copper will deposit at anode. Copper cannot deposit at anode, okay. Deposit means it is reduction only, okay. Copper will dissolve at anode. Copper dissolve means copper is converting to copper 2. This is a salt, so it can dissolve. Okay. So next question, conductivity kappa is equal to, you have to derive the expression, that's all. We know that resistance is equal to the specific resistance into the cell constant, and conductance, which is the reciprocal, okay, of the resistance, is equal to kappa into the reverse of the cell constant. You know that kappa is the inverse of the specific resistance. We call this as specific conductivity. This is conductance, this is specific conductance or conductivity. So the kappa is equal to G, okay, conductance into L by A, okay. We know that G is equal to 1 by R, okay, inverse of resistance. So this expression is correct, okay. We know that cell constant is often, okay, is represented as G star, okay. If you put G star, this is also correct option, and the rest two are not. The molar conductivity of ionic solution depends on, as we already discussed, depends on temperature and the concentration of the electrolytes, and the rest two are wrong, okay. For the given cell, magnesium and copper, okay, so which of the statements are correct? See here, this is acting as anode and it will undergo oxidation, and this is acting as cathode, undergo reduction. So magnesium is a cathode, no. Copper is the cathode, correct. The cell reaction is correct. Magnesium undergoes oxidation and copper undergoes reduction. Copper is an oxidizing agent, no, this statement is not correct. Not copper is an oxidizing agent, copper 2 plus is the oxidizing agent here, okay. So not the copper. So I hope this helped you to some extent. If you feel no, it's worthy, please share with your friends. Thank you.